All right. And we're going to go over topic 24, which is enums. Okay. And simply put, an enum is a collection of constants. Okay. And if you remember, a constant is a variable whose value doesn't change. And when we name it, we usually have all caps or underscores, right? And here I have an example of an enum, right? And then we can define multiple enums. In this case, we just have value 1, value 2, value 3, and we separate them with a comma, okay? And then in order to define it, it's sort of similar to the syntax for class, but instead of the class keyword, we're going to use the enum keyword, and then we're going to put in a name for our enum, and this also becomes a little bit like a type, okay? It becomes, an enum is a type. I think it's a subset of a class, yeah. But either way, and then you use your curly brackets, and then you define your enum values. And then enum values initially are valueless, meaning we're really used to having variables where like we assign an explicit value, like this integer has a value of 5, this string contains so and so characters, it says hello world, etc. But here, enum constants are technically valueless, but you can assign them attributes. So you can almost imagine as if an enum is an object, okay? But let's just break this down really quickly, okay? So just like our enum before, right? On the top, we have our keyword enum to tell Java that this is an enum, our name, which is an enum with attributes, and in curly brackets. We define our values, value underscore 1 and value underscore 2, but this time, we also have parentheses where it looks like we're passing in parameters. It looks like we're calling a method, right? Or we're actually calling a constructor. So you can see here, if I get my pointer, you can see here that we have a constructor here that has two parameters, attribute 1 and attribute 2. One is an integer, one is a Boolean, and then you assign it to you can assign it to these member variables here of the enum. So now value underscore 1 will have an attribute, will have attributes with these values with 1 and true, and value underscore 2 will have attributes of 2 and false. So when you reference them, you can get these attributes out of it.
Can I jump in for a second on the previous
Mm-hmm.
slide? So you can kind of think of when it's defining the different values within the enum. I'm not exactly sure valueless is the perfect word for that, because what you should really be thinking of is those constant value 1 and value 2 are the values that the type and enum with attributes can have. And then the attributes are inside those values. Anyway, when we write value 1 and then 1 and true in the parentheses there, you can kind of think of it as calling the constructor below. And you could actually have methods within the enum that so that you could make those encapsulated and such.
Yep, that's right. Okay, and we're going to talk a little bit about the uses of this, and Grady, if you want to expand on this, you can. So to be honest, the most often we see enums being used are actually in conditionals. So like if statements, is this enum matching this enum, blah, 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 blah. And they're really useful when you want to create like types in your code, for example. And so that's like when you want a particular type to hold a specific set of constant values. Okay, and there are some examples of this, like if you're defining a menu never changes. You just want to know like which one's being clicked or whatever. You can assign each of the menu items to a enum. That's good. Command line flags. Again, like for example, if you have to type in a certain command line flag or command or something like that, that can be considered as an enum as well. And our run modes, which are very commonly used actually. So whether or not you're in production or in development mode, or I don't know, autonomous or teleop. Okay, and those are use cases for an enum where the value of the enum itself doesn't matter as much. What matters is that this enum is this specific enum. And then I'll show you how we use it. And this is an example with production development. So here in top, I have an enum declared. It's called run mode. Okay, capital R, capital M, just like the class. And we have two enums defined here, production and development, and in all caps, because that's the way we generally name constants. And now let's go and take a look how we use it. So we have a class my app, which is my application. And then here in the public static final run mode, we have a variable, we have the type run mode. So enum, technically when you make an enum, you're making a new type. So public static final run mode, and then the name of my variable, which is just called mode, is equal to run mode. So now I'm referring to this enum dot production. So now this variable will have the value of this dot production, okay? And I just have a random integer variable here. And this main function, when I run it, I'm gonna get if mode is double equal to run mode of production, then I'm gonna print out this and I'm gonna set the sum into this. And then if I have mode is equal to run mode of development, then it's gonna say running development mode, and then it's gonna set sum into a different number, and then very end I print this out. So what's useful here is you can see in this comparison, we didn't have to do numbers. We didn't have to say, if we're in production mode, type in 1. If we're in development mode, type in 2. No, we don't need to do that. All we have to do is say, is this variable equal to this enum? We can directly compare, and you can already sort of see how we can use like sort of types with this in a situation where you need types. Okay, and you have to do something differently. And if I run this code, we can do a small little example, I guess. Let's do this. Oh. Just copy and paste this. Enum example. Okay, I'm going to share my IntelliJ. Share software lessons. The enum values do have type. They belong to the name of the enum. Okay, so you can see here, run mode.production is of type run mode. Okay, Yash? Does that sort of make sense? And then, so right now, as the code is right now, we have run mode.production. So what do you guys think this very last system out.print line will print out? You guys can say in the chat. So remember, depending on what the variable this is going to print out something different, right? What do you guys think, what number is this going to print out at the very end of the code as is? I'll give you guys some time to think about it. And when you guys know, just type it out in the Zoom chat. Okay, I've got 2 people who answered it. 3. Okay, very good. So yeah, because the variable mode right now is equal to run mode.production, this if statement is going to be called, and the sum in is going to be set to 5, and then when we print this out, it's going to be 5 times 5, which is 25, right? And what if I was to change this to development? What do you guys think? Oh, what the heck? Whoa. Let's try it again. It says it doesn't like it when I jump places. Why does it care about this? Try it again. Okay, there you go. There you go. Yep. Oh, 150. Oh, right, because we're in development mode. Oops. But yeah, if we change the development, then it's going to be 30 times 5, right? So that's going to equal to 150. And if we put it into production, it's going to give us a different answer. So, for example, if I want to make this applicable to what we do with our robot, I can say that, like, for example, if we are in debug mode, for example, debug meaning we're constantly working on, we're trying to fix things, we want to know all the information. We're gonna just be collecting so much information from the motors and encoders that even though it might not be viable in an actual match because we want to like not use up all of our CAN bus bandwidth, that might be really useful in development mode. But we can have the code so when the enum is set to production, it's not going to be spitting out that much information. It's not going to be grabbing that much information. So you can see how we can change the behavior of the code just with one single change of the enum. And that's because it's really elegant to be able to just use an if statement, double equals, and just say run mode production. Okay. And just a really quick note, you can use this in a switch statement. You can use this in a switch statement. You just do this. Okay. So enums are totally useful in a switch statement, and actually, I think you will see them in a switch statement more often than not, especially when you're dealing with multiple of them. So let's go ahead and get back to the slides. All right. Do I have any questions on how enums work right now? Does anyone need any clarification on like when to use, how to use them, etc.? All right. Seems like everyone is good. So I'm going to go ahead and move on. We're going to talk about nested versus inner classes. Okay. And then here on the left, I have a nested class, or here on the left, we have our like array function. Here on my right, I have the definition of them. So there's a lot on the screen right now, so we'll go over them slowly. Basically, and this has to do a little bit with terminology. A nested class is a nested and inner classes are both defined inside another class. Okay, but nested classes are static, whereas inner classes are non-static. Okay, so there's actually a little bit of a terminology difference there, even though they both belong in the same place. Okay. And the difference between a nested class is that a nested class, because it is static, acts like a totally um, it acts like a totally normal class. You can make an instance of that inner class, even though you can make an instance of the inner class, or sorry, you can make an instance of the nested class, goodness sake, of the nested class without an instance of the outer class. And you can see here in the first two lines, um, we just say static outer dot nested. Nested is equal to new outer with a capital O dot nested. So you can see here we've completely skipped the instance of outer that we made before. We've directly created a new instance of the nested inner class. Okay, and you can see here a nested. We say public static class nested, and you can see it's inside our outer class here, and it has its own methods and whatnot, right? Now let's go and talk about inner classes, okay? Inner classes are defined in the same way. You can see that it's also inside this outer class here. You can see inner is defined here, except we're missing the static keyword. And now, in order to make an instance of this inner class, you have to have a reference to an instance of the outer class. So here we say outer, this is a variable, right? Not the class itself. So we're referencing this variable in instance of outer dot new inner. And the reason for this is because a static nested class is not able to access the member variables of the outer class. But because you make an inner non-static class and you have to make it from another instance of the outer class, the inner class will have access to the member variables of the outer class. Okay. But otherwise, once you initialize them, they all act the same, except that inner can access the member variables of outer, static cannot. And there are some use cases for them, okay? Nested classes, the static classes, they're useful when you need to define a normal, regular class, but it is inherently tied to the class that it's under. And what I mean by that is like it's directly related. For example, a rectangle class may have to be defined by a class called point, but you don't want to put point in a separate file in its own little class. You can make it a nested static class, okay? And an inner class is useful when you need a class to do things within another class, but you don't need to really use it anywhere else in the code other than the class itself. It doesn't have to work with information other than the class itself. And that's where an inner non-static class might be really useful. Okay. Does this sort of make sense to everybody, or is this kind of confusing? Because they sound very similar. Their code is the same, but they do have different jobs and roles. If you
Samuel,
guys are all good with this, can you guys put a check mark that says yes?
Samuel,
Yeah.
I think that a key thing to understand about the difference between nested and inner classes is that because the nested classes are static and the inner classes are not, the inner classes are going to be associated with a specific instance. So the point of making an inner class would be to have code that you need to be done in a class within a class that needs to be directly associated with the instance um instead of the class in general.
Yeah, I think that's what I was trying to say, but I guess I should have written there's an instance in here somewhere. But yeah, you're absolutely right. Okay, so is everyone good on this? If you guys can like do the yes thing in the participants menu, just to make sure that I'm not going on too quick. Okay. I've only got 2 people to respond. Okay, looks like this is confusing to some people. All right, Marco and Yash, what about this is really confusing right now? Or are you guys just in general kind of lost? You guys can ask like you guys say it in the chat or just unmute. Can we go over the example again? Yeah, sure. So take a look at the example code and just pay attention to how we define these nested and inner classes, okay? And we have public class outer, right? And that's we're already really used to that. We say class, the class name, and then we say the curly brackets, and we start writing our code, right? And then instead of making a whole new file for the class, we just directly put the class inside another class, okay? So public static class nested, you can see these curly brackets are completely inside these curly brackets, right? Same with the inner, okay? So they're completely inside the outer class. And the only difference between these two right now is that one is static and one is not. So the static one is not tied to the instance of outer, but the inner is tied to the instance of outer. So inner is able to access the member variables of an instance of outer, whereas nested more or less acts like a normal standalone class. Okay. All right. And Marco, do you have any questions? Okay, cool. I'll clear off everybody. All right, we're gonna go into exceptions, not exceptions, topic 26, and these are exceptions and try-catch. And you are, when we get to larger and larger products, these are gonna, how you handle these will be very important to how reliable your project will become. And if you ever try to screw around in code and you notice that your code compiles but it does something wrong, you might get your IDE might spit out some red text. In this case, we have an example of arithmetic exception where you divide it by 0. We all know in math you cannot divide by 0. So when you try to do something like that, Java is going to throw an exception, meaning something went wrong. Okay. And nice thing is it tells you the stack trace, meaning what code led up to the what code was led what code eventually led to the execution of a line that caused an error to happen. Okay. And so we're going to talk a little bit about try-catch expressions. Okay. And just remember, the exceptions are thrown. Well, we use the word thrown. They show up whenever you do something that Java doesn't like. Okay. That's something that's not allowed. Okay. And a try-catch is basically, usually when an exception is thrown, your entire code crashes. Okay. It immediately terminates. And then any code after when the exception was thrown will not be executed. Okay. And what do I mean by that? I'm going to really quickly try to make an example here. Can I share my screen? I have a little piece of code here for an exception that we'll come back to later. But you can see here how I wrote throw new exception example, right? Any code that I put after here, because it's thrown, this code will never ever be called, and you can see IntelliJ actually recognizes unreachable statement. So because when you throw, this method now terminates, and then code after that is not going to be run. But if you were to put a try-catch statement, that's not going to happen. That's why try-catch statements are really important to writing reliable projects, because you need the try-catch statement in order to handle an exception properly, know what to do with it, and then keep running the code. And this is especially important when we're talking about a robot, where sometimes there's a lot of numbers being thrown around and whatnot. Exceptions will happen. Sometimes the motor controller will fail or whatnot. We need to make sure that our code will continue running and it won't just crash and terminate on the spot. Okay, and that's where try and catch exceptions come into play. And try and catch are kind of like an if-else statement. The first part is a try, the second part is a catch, and they're both separated with curly brackets. Try means we're going to try the code in here, okay? And if the code has an exception, we're going to catch it. We're going to save it to a variable. You can say here, see here, we're catching exceptions with a type of exception, which seems very broad because it is. And then when an exception is caught, we're gonna run system.out.println caught exception, and then we're gonna print stack trace it. Okay. And then and I said how exception is really broad, right? You can go very specific. For example, 1 divided by 0 will specifically throw a divide by 0 exception. So we can say catch divide by 0 exception, and then we can do something very specific with it. Okay. And you might have noticed here that the word exception divided by 0 exception, they have the same naming convention as a class. That is because they are a class. Okay. And then I'll go into this a little bit later. It ties into the inheritance lesson, but I want to talk a little bit more about try-catch exceptions. Okay, let me get some IDE that I can like properly do something here. So share IntelliJ. Here we go. So here we have a main class. I hope you guys can all see it right now. And then I'm just gonna do this for now. I'm gonna have the exact same code here. I'm gonna do 1 over 0, and you're gonna see that you're gonna go ahead and see that if I try to run this code, I just ran the wrong main function. Oops. When we run this code, 1 over 0 is gonna throw an arithmetic exception, and it's gonna catch it. And yeah, okay, you can see here, system.out.println, we caught an arithmetic exception. Okay. And then, so because an arithmetic exception was thrown, this piece of code is now gonna run. But if we did perfectly valid code, like 1 divided by 1, for example, this catch block is not gonna run. You can see here it's just completely empty because an exception was not thrown. And a really cool thing about Java is that you can actually have multiple catch clauses. For example, you know how I said exception is a really broad one? It means it catches every single exception. If it's not an arithmetic exception, it's going to automatically go into this one. So I can say we caught an unknown exception because it's so broad. Every exception is a subclass of an exception. They're all types of an exception. Okay. And right now, 1 over 0 is still specifically an arithmetic expression, right? Okay, so it's just divided by 0. But what if I do something like, I don't know, let's go ahead and try defining an array, okay? Integer x is equal to new int with a size of 1. And let's say I want to do something that is not allowed. I'm going to try to set a value to the outside of this array, okay? So I'm going to go ahead and say x is equal, x of 3, I don't know, just something out of bounds, okay, because this is the size of 1 and I'm trying to access the 4th element, okay? This is technically not, this code will compile. There's something syntactically wrong with it, but we're going to get an array index out of bounds. And you can see we call it an unknown exception because this is not an arithmetic exception. This is an array index out of bounds exception. So it will end up going to the super broadcast statement of exception, and then we say we call it an unknown exception. So you can see how, depending on the exception that is thrown, we can do something different based upon it. And code after it will continue to run. And we say, I am exiting now. Code after that will continue to run. The try-catch statement will prevent your code from being suddenly terminated. Okay, see, I am exiting now. Let's go back to the slides. So, and then real quick, I'm going to talk about method exception signature, okay? Because sometimes it's better to not handle the error immediately and have it to be handled higher up in the code. And what I mean by that is instead of having try-catch statements everywhere in the code wherever an exception might occur, you can see how that might quickly make your code look really ugly and hard to read, right? The key, and you want to add a keyword throw to the method, and the exception will be thrown upwards in the method call stack. And what do I mean by that? Here in this code, okay, I have a try catch statement in main. And you can see here, I'm only calling a method do arithmetic exception, okay? And then if there is an arithmetic exception thrown, I'm going to do something. I'm going to just print out the exception, right? So do arithmetic exception is going to do 5 divided by 0, which will throw an arithmetic exception, right? Normally, we don't have a try and catch statement here, so the code is just going to terminate, right? No, because we told the method that, okay, if you get an arithmetic exception, don't terminate the code yet. Go and just throw the arithmetic exception to the method I called you. And what method called do arithmetic exception? The main method. The main method called do arithmetic exception And because if through an arithmetic exception, this try-catch statement will be set. So even if I call another function here and then another function and then another function, as long as it gets thrown upwards, this try-catch statement will handle the arithmetic exception. Okay, and this can prevent you from writing try-catch statements everywhere in the code. You can find a common place where a try-catch statement will make sense. Okay. And now I'm going to get into utilizing inheritance with exceptions. Okay. And you might have noticed that the exceptions are classes. That also means all the more specific exceptions are technically subclasses of a really big exception called Moses exception. And it also means you can write your own exception. So here we have exception, right, at the very top. And then we have some subclasses, which I looked up in the Java doc. We have runtime exception, which is probably the most common you'll see. And there's some more niche ones called like unmodifiable class exception and whatnot. So these are children of exception, right? If an unmodifiable class exception gets thrown, you can catch it with an exception. But unmodifiable class exception will not be called by runtime exception, right? Because that's how inheritance works, right? And runtime exception has even more subclasses. It has even more extensions. So we have a raised store exception, arithmetic exception that we just saw, unknown entity exception, index out of bounds exception, and all of these can be caught in runtime exception, which can be caught in exception. So you can see how there's many layers to how specific you can be when you want to say, I want to catch an exception, okay? And so that also means because exception is just a class, you can write your own exceptions. And here I have a very, very simple exception example. Here in this first part, I have a public class exception example, and it extends exception. So I'm now making a subclass of this exception, right? And I'm just going to override the default constructor and set our own default message. I'm going to say exception example super, and I'm going to pass in a message. Okay, this is defined in the exception class. If you look up a Java doc, you can override it. And then in order to use the actual exception, I have my main function here set up to throw the exception example, right? I can just say throw new. I'm going to make an instance of exception. I'm going to throw an instance of exception, new exception example. And then now I'll see exception in thread main, exception example. And I have my method, exception example thrown, and I have my stack trace. So sometimes when you want an exception to have more description about what actually failed, because you know what failed, you can write your own exception. And we do have that in robot code. And that's it for exceptions for now. I'm going to leave it on I'm going to leave the slide on this example. Do I have any questions for exceptions? If you guys don't have any questions, can you guys respond with yes in the participants box? Okay. So the super keyword here, it means that it's gonna call the constructor. It's gonna call the constructor of the superclass. Okay, but basically the class above it, right? Because an exception example is a subclass of exception. So exception is now the superclass. So when we say super parentheses, we're calling the constructor. Okay, and throw means you forcibly throw an exception. So instead of like saying 1 divided by 0 to cause an exception, you can go ahead and directly cause the exception. So for example, if I wanted to, right, instead of throwing my exception example, I can actually directly make an instance of arithmetic exception. And then that way, it was going to throw an arithmetic exception now instead of an exception example, okay? And sometimes you want to do that when you just want to, like, if you had an if statement, for example, okay, if you have an if statement, these parameters do not work out, I'm going to throw an exception, okay? So that's a sort of a common practice. Any more questions? Amrik, do you have any questions? Brendan, do you have any questions? No. I'll just go one by people. Oh, okay. If you guys don't have any questions, please put the green check mark. Okay. Okay. All right. So you guys are all comfortable with this so far, right? All right. That is the last topic of the day. Because next class we will be going over something complicated. Grady, do you think we should do a practice for this?
Yeah, do something.
Okay.
Even if it's not directly focused on this, but yes,
Yeah.
definitely do something.
All right. Okay. How about this? All right. Uh, hmm. Let me see. So, let me think for a second. I need to make up a example for this because practice it actually does not have an exercise for exceptions, unless you can find one. Let's see. Right. Okay. We don't have any assignments for exceptions either. Okay. I'm gonna go ahead and make a statement right now. Okay. We're gonna go ahead and do the Rexel thing, or not the Rexel thing. What's it called again? The tool that we used last class in order to have a collaborative.
REPL.it.
Yeah, REPL. That's what it's called. All right. Okay. All right. I'm gonna send the REPL.it into the Zoom chat, and let's go. I'll go in there. 542. Okay. And then I'll go ahead and write a building sample prompt. Okay. Can you guys all make a folder with your name in it? With your name as the name of the folder in the workspace. So you can see here, I should pop up soon. I have a folder called Samuel. If you guys could do that, then we can start doing practices. Right. All right. The question is almost ready. Okay. Check type. All right. Everyone, make a file inside your folder called enum practice. Okay. Like this. Oh shoot. Name it enum practice like that, or enum practice.java. Okay. Okay. There you go. All right. Question is done. All right. I want you guys to go and take a look at my IntelliJ really quickly. Your job is that we have this my enum. Okay. Yes. Type 1 and type 2. We have my class, which is we have my class, which has a member variable called my enum, and its variable name is type. And I want you to, for this method, implement check type, where an instance of my class will be passed in, and then you have to check if the instance is type 2, right? Like up here, type 2, and you want to print to console yes or no. Okay, and I'm going to go ahead and define these my enums inside the REPL, just to make sure that you guys are able to take a look at it yourself. My enum.java. And when you guys are finished, go ahead and do the green check mark, and then I'll check on you. Yash, the problem is, I'll go ahead and make a file in the workspace called exception practice.java. You can only see a small part of my screen. Okay. Here, how
Okay,
about?
I wasn't sure if that was just me, but yeah, we can only see the bottom status bar line on IntelliJ. Oh, now we can see it.
Okay. All right. I want you guys to in exception practice.java, I need you guys to implement check type. So you guys can go ahead and copy and paste this into your enum practice.java file, and then you guys can get started to work on this check type method. Good luck. And then me, Daniel, and Grady will go around. I guess we can just add comments to their file, huh? And if you guys have any questions, just DM any one of us free on Zoom, and then you'll be fine. Vinny. Okay, Vinny's confused. Oh, actually, you know what? All right. I'm gonna make this a little bit more fancy. Okay. Everyone, check the exception practice.java file. I'm adding a challenge. Okay. If the instance isn't of type 2, throw an exception. Okay, so that's an actual challenge. Okay. Oh, I think we just lost Marco. All right. That's okay. Samir, if you you know what to do right now? We kind of lost. Okay, I'm just assuming that for some people that it just takes a long time for it to update. Grady, are you able to see Vinny and Wendy's code, or are they just empty for you right now? Okay, Daniel can see nothing. All right.
Both
Well,
are
last time
empty.
it took like 2 minutes.
Yeah, both are empty for me. Well, I see Vinit typing,
Okay.
but maybe it's like a minute or two behind.
Yeah, I think so. All right, I'll go check. Okay, this is good. Uh, Brendan. Okay, Brandon and Vinny, if you want to do even more, I've added a main function in exception practice, and you can go ahead and try that out. Vinny, yours is good, and Brandon, you too.
You guys aren't going to be able to run your code very easily, but I guess we can play compilers. Um
Yeah, we can just check the compiler. All right, Amrik, let me go check her. Okay, Samir, let me go take a look. Samir, do you realize that your enum practice.java is empty? Or is that just bugged? Yash, the challenge is in the exception practice.java that you copied from. I added more comments there. You can see the instructions in the file. So it's 3:59. If you guys are finished, if you guys have done the check mark, you guys are free to go. But if you want to try to finish this, I can stay for about 5 minutes longer, and I can check the work for you. And we have a small problem right now where sometimes REPL doesn't seem to update all the time. So if you ask us to check, if you ask us to check, and then we go there and we see nothing, you can just DM us the code on Slack, or not even DM. You can just reply in the agenda in Slack today. Bye, Subrov.